let's take a look at one class that is taking a pass-fail exam. And the class consists of 25 seniors and 35 juniors. Now, I'm going to refer to the set capital S as being the set of seniors and the juniors as being the set capital J. I'm warning you in advance, I should have used a different letter because normally when I say the number of elements in S, that means the number of elements in the sample space. So I'll try not to use the word sample space, but if I did, I'll write it out like this. The number of elements in the sample space is what? How many students are there in this class? 25, 35, that makes it 60. Capital S will be the set of seniors. All right. So the number of seniors, which we could just say is N of S, is 25. The number of juniors, N of J, is 35. Well, let's look at a tree diagram first. We don't use these too frequently, but we could say that taking this path is the senior path. There are 25 seniors, 35 juniors, and then we've got pass and fail, or pass and not pass, like that. If you're a senior, you either pass or you fail. If you're a junior, you either pass or you fail. And let's write the numbers down. Let's see, 9 seniors passed. So where am I going to write that 9? We'll take the seniors path, and then I'll put 9 right there. And that means how many failed? 25. There'll be 14 of them who failed. Is that right? Or sorry about that, 16 who failed. 16 and 9 add up to 25. 9 passed, 16 failed. Of the juniors, 5 of them passed, which means 30 of them failed. Now let's draw a Venn diagram. I'm going to make this one a little bit different because I could draw a circle for the seniors and a circle for the juniors, but they don't overlap. They would be two separate circles because no student is both a junior and a senior. So what I think I'm going to do is, up here I'm going to write the number of elements in the sample space is 60. I'm just going to cut this set in half. It's obviously not, the size doesn't necessarily matter of the two sets. So I'll put the juniors here and I'll put the seniors here because there's nothing else other than juniors and seniors. The sample space is the 60 students and they're separated completely into juniors and seniors. And then I need one more circle that's going to be the number who passed. All right, so for example, this half circle right here is the number of juniors who passed. This half circle here, the number of seniors who passed. So what would this region be? This region is in the seniors. It's not in the circle of those who passed. So this is the failing seniors, and this would be the juniors who failed right over here in this region. So let's fill in the numbers appropriately. I'm going to start from the inside out. Again, if you want to make a note, this is not really part of the Venn diagram. It's kind of a cheat number that you're allowed to use, and I always use this. How many juniors are there total? 35. So the total number in this left half has to add up to 35, and the seniors have how much? 25. 25. So whatever you put in this half circle in this region has to add to 25. Whatever you put in this half circle and this region here has to add up to 35. So let's do the inside first. 9 seniors passed. So here's where the 9 go. They're in the senior section and they're in the pass circle. 5 juniors passed. So what number goes out here with 25 seniors? 9 passed, so we put the 16 out there. And 35 juniors, 5 passed, so we put 30 out here. And notice that all 4 of these numbers, if you add them up, will add up to 60. Just like it, yeah. Here's a tree diagram and Venn diagram that basically represent the same thing. I think the Venn diagram is a little bit more clear. All right, so before we move on, these 16 students, each one of them in an element of the set capital P? No, they didn't pass. These would be the 16 elements in S and the complement of P. So, I mean, I could just say fail, but the complement of P means you failed. So the set of students who didn't pass are in the set of students who failed. So I'm not going to use F, I don't think. So, all right, so let's use these diagrams. Now that we've got everything filled out in the diagrams, these questions should be pretty easy. All right, the number of seniors and passed. That means the number that are in the group of seniors who also passed. You have to be in the senior group and in the pass group. So this means the number of, in S intersect P, S intersect P, where does this right half and the circle intersect? Right there, 9. That's equal to 9. The number of seniors and not passed would be the number of elements in S intersect and failed, or in other words, the complement of P. So S intersected with P complement is going to be this 16. You've got to be in this region S, but you can't be in the passed circle. You didn't pass, so you're out here. So that's going to be 16. Okay, how many elements are in the juniors and passed set? Well, that's the number of elements in J and is intersection, remember? Intersect P. Well, J intersect P is this semicircle right here with that's got 5 elements in it. Juniors and not passed, we would write in J intersect P complement. Not passed just means they failed. So how many would that be? In the junior side, not passing would be 30. So we just showed how to write out in this form, using S and P complement, each one of these 4 numbers. We've got all 4 of those numbers. I can write that there to be consistent. All right, well, the next line says find the probabilities associated with all of this. So I'm going to go ahead and write the probabilities in here, which is going to be very simple. The probability of S intersect P, by definition, is the number of elements in S intersect P over the number of elements in the sample space. Goodness, so I have to reuse S. I'm going to put the number of elements in the sample space. S means a set of seniors. I should have written this problem with not even sophomores, with freshmen and juniors. I'm only putting this number of elements in the sample space because I don't want to repeat this S. It's a different S. So this numerator is just the number 9. And how many elements are in the sample space? The whole thing, 60. Maybe I'll do this. I'm going to say the number of elements in sample space equals 60. I'm only doing that because I accidentally called one of the sets S, this one. So I'm going to call the whole thing SS for the sample space. All right, and how many elements was that? 60. That's the probability. And what that means is the probability associated with this means if you randomly select somebody from this set, randomly select one of the 60 people, the probability that that person is senior and passed is 9 over 60, because 9 out of the 60 people are seniors who passed. Okay, so this one will be the number of elements in S intersect P complement. Well, we already know the numerator. That's the number of elements in S intersect P complement over the number of elements in the sample space. So this is 16 over 60. All right, so the number or the probability that the randomly selected person is a junior who passed would be probability of J intersect P is the number of elements in J intersect P over the number of elements in sample space. This is 5 over 60. And finally, the probability of junior and not passed is the number of elements in junior and not passed over the number of elements in the sample space, which is 30 over 60. Well, that's a nice round number. That's exactly 1/2 that probability. So if you randomly select a person from these 60, 1/2 of the time, 30 over 60, you're going to get a junior who did not pass. All right, so now we have a couple more probabilities to do before we finish this video. Just like above, suppose one student is selected at random. Find the probability that, and again, you can see my mistake here. I should not have used P for pass, but because if P is inside the parentheses, it means passed, the set of students who passed. If it's out to the left, it always means the probability. So what is the probability that the randomly selected student passed, given that you chose a student from capital S, the seniors? So this is equal to, by the formula, the number of elements in P intersect S over the number of elements in S. And once again, this is not the sample space, this is the number of seniors. So how many students do we have in P intersect S? Here's P, that circle. S is this half. So the circle and this half intersect with the 9. We actually did that up here already. So this is 9 over the number of elements in seniors, which is 25. And again, we've been over this, but I'm going to mention it one more time. If we have given the person was a senior, the probability that he passed, given the person was a senior. Given the person was a senior really means this is your whole picture. So you only have 25 people to choose from. 9 of them passed. 9 out of 25 passed. And this formula does the same thing. All right, the probability of not passing given senior would be the number of elements in the intersection of those two over the number of elements. This is actually S. Again, it's the same S as this, the seniors, not the sample space. This is equal to, let's see, did we get that one? The number of elements in P complement intersect S is right here. They're written in opposite order, but these two things are the same. So it's going to be 16 over 25. And that kind of makes sense. Given that the student was a senior, there are 25 possibilities, and the number who passed was 9. The number who didn't pass was 16. 9 and 16 add up to 25. So you've covered all of the seniors there. Now, the probability of pass, given that you're a junior, is the number of elements in pass intersect junior over the number of elements in junior. So what's the number of elements in P intersect J? We got it right here, 5. That's this number right here. 5 over, how many juniors were there? That was 35. And then this is going to be the number of elements in didn't pass, not passed, intersect junior over the number of elements in junior. So let's see. Juniors and didn't pass. Where do we have that? Juniors and didn't pass. So that's 30. That's this 30 right here. In the juniors, but not in the pass circle. So that's going to be 30 over 35. And just like with the seniors, the probability, given a junior, these are the only two possible cases. You either passed or you didn't pass, given that you're a junior. 5 out of 35 passed. The other 30 out of 35 did not pass. And we'll continue this in the next video.